All right, what's up? This is Algebra 1 Standard Honors. Oh, we ain't got to read all this. We got the date. We got the date right there. Okay, quiz number 1. St. Augustine High School, and I am Miska. All right, that's what's up. Okay, I'm going to go through this quiz, and I'm going to go nice and fast because, hey, if you miss something, you can just go back and listen again. So we don't have to take a long time explaining things uh, that you can just repeat. This is great. So, first thing, question number 1. We want to define what prime is. What is prime? Okay, well, first, here on the bottom, I'm going to write some prime numbers. You should know these, okay? Like, if someone asks you to recite the first couple of primes, you should be able to do it up to this, This is 19, what's left? 23, and, of course, they go on forever. They go infinitely on. Um, the chances are is that whoever asks you if you could recite the prime numbers, they probably get pretty bored after this. So if you can make it to 13, you're good. And I think Algebra 1, you're not going to be doing prime factorization with numbers that have primes bigger than 13, most likely. Let's see. So if I want an actual definition, I would say that it's a number that can only, and this is important now, you got to have that word in there, only be divided by itself and 1. Okay, common mistake I see is kids leave this word out. And so it looks like this. A number that can be divided by itself and 1. Well, that's every single number there is. You can divide any number by itself and 1, but the thing that makes prime special is that primes can only be divided by themselves and 1. That's what makes them special. That's what makes them prime. So be sure, if you give me that definition, that you include that word. The language that we use in mathematics is very important. We can't have answers that are kind of half true in writing, because when you say something in writing, it's got to mean exactly that. Let's see if this works. No, it does not. I ain't as good as this as I thought. Yes, I am. Define factor. Okay, so I'm going to start with an example. And anytime I do something like this, a quiz, I mean, if you're having a hard time trying to explain something to me in words, it's fine to give me an example. So here's an example. I mean, we want to work on being able to write math out in words, but if you understand the concept, that's the most crucial thing to me. So what I have here is some numbers multiplied together, and then something that they're equal to. Well, what they're equal to here, this thing, 8, that's called the product. A product is a solution to a mathematical problem, okay? A mathematical problem involving multiplication. So here's multiplication. All right, there's the multiply. I'm not lying. It's multiplication. You put them together with multiplication, and what you end up with is a product. Okay? 8 is also a composite number. It's composed of factors. Okay? It's the opposite of prime. And these numbers are prime. I hope you notice. 2, 2, and 2. And since they multiply together to give me a product, that makes them factors. And that's what the definition of factors is. I would say elements or values, you know? I don't know, numbers. How about that? And you can start off with any of these. Numbers, elements, values, these things that multiply together to form a product. A product. Okay? Things that multiply together to give a product. That is what the factor is. So 2 is a factor of 8. Okay? Blah, 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 blah. Blah, blah. Bam. 2 is a factor of 8, okay? Or these are prime factors, 2, 2, and 2, but like if we mixed it up a little bit, 4 times 2, I mean 4 is also a factor of 8 because if we multiply 4 and 2 together, we get 8. That's what makes 4 a factor. It's one of the things that we multiply together to get 8. All right, so I'd accept that. It doesn't have to be prime, but I mean that is what we're talking about. You should be comfortable. All right, it should be like a nice big cushy sofa. You sit on there and relax. You shouldn't be stressing out, okay? Study your notes. LCM, that stands for least common multiple. So, East common multiple. Okay, it doesn't make much sense, but if you attach this to it, then it does. Least common, that's the C there, a multiple, all right? Least common multiple, and it looks just like this in your notes, except, you know, I didn't use these teeny tiny letters. I had a regular old pen strokes. Least common multiple, that's what it stands for. I talked about what a least common multiple was. Gosh. Come on, girl. There you go. Oh, no. Yeah. I'll have to practice that. Show the prime factorization of 40. I'll go back to least common multiple when we work one and talk about it. But let's talk about prime factorization first, since we actually have to know what prime factorization is to find the least common multiple. So the technique I use is the tree, the factor tree. The factor tree. What we're going to do is we're going to grow our tree. Okay, so we're going to start with 40. I hope I have room. And then I'm going to grow my tree. Grow your tree. Look at me. Yeah. There it is. Now, prime factorizations are unique. Like 40, this number only has one prime factorization, but the factor trees themselves aren't unique. The tree can grow in other ways. So don't be upset if your tree doesn't look exactly like mine. Let's say you did 5 and 8. That's 2 and 4. That's 2 and 2. You'll notice that I have 2, 2, 2, and 5. That's 2 times 2 times 2 times 5, which is the same thing as, by the way, 2 to the third power times 5. You better be able to do that. And that's 40. And over here under red tree, I have 2, 2, 2, and 5. 2 times 2 times 2 times 5. All right, 2 different trees, but they get the same thing done. They both do the job. All right? So what? Throw it in there, man. Bam. 2 equal signs. We're gonna what? Oh my gosh. 2, 1, 2, 3. Okay, we don't play around in my class. We rock it up with 3 equal signs. Next page. Let's show the prime factorization of this big boy. This is a big old boy right here. If you've got an issue with a number like this, if this makes you sweat, then hey, you may want to bring a calculator, okay? You may want to bring a calculator to class. I did this in class in my head. Well, not necessarily. I did it on paper. But it took me a while, you know, and I'm like a pro. Oh, I'm semi-pro. I'm semi-pro. I wouldn't want to lie to you. 2,310. We're going to build a tree. It's a big old tree. The bigger the number is that we break down, the many more different ways the tree can look. So I'm not going to show examples of how the tree can be different for this. I'm just going to go ahead and break it down as best I can here. Well, this is the same thing as 10 times 231. And I could have divided it by 5 because it ends in a 0. It ends in a 0, that's pretty special, okay? If it ends in a 0, you can divide it by 10, you can divide it by 5, and you can divide it by 2, typically. So I just chose 10 because I want to break these numbers up a little more quickly. That's 2 and 5. Now, 231 is a tough one. Okay, so if you're having difficulty with this, you may want to whip out your calculator. No, 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 I'm happy. I'm happy here. No, thank you. No, no, this is good. All right, there you go. So we get a little calculator out, and we have 231, right? And what do I divide by next? Well, you should start with primes. You should only divide by primes if you can. And we already used 2 and 5, so we don't need to test whether 231 is divisible by 2 and 5 right now. Let's try and divide it by another prime. So let's divide it by 3. So then I'm going to divide by 3. And what do I get? Bam, 77. Thanks. I can take it from there because I can divide 77 in my head. That's 11 times 7. 11, 7, and 3. Notice at the end of the tree, you only have prime numbers left. That's the idea. There's also this thing called upside down division. I don't like it, but you know what? The more you know. 2, 3, 1, 0. This is how upside down division works. Like I divided it by 10, and I got 231, and then I divided by 3, and I get 70. I'm not very good at it. In fact, I think I may have messed up. And you divide that by 11, and you get 7. I screwed up. You know, that just goes to show you I don't use upside down division a lot, because I should have divided by a prime number up here. I should have divided by 10, because then 10's not prime. So you'd have to break it down to be 2 times 5. So I screwed up. But that's the concept of upside down division. If you like it, then Google it. If you're looking at this, then you can Google. You're a Google master. I don't have to tell you about it. You guys are the tech generation. I'm just trying to catch up. Please, this is great and all. I mean, you found the prime factorization, but it looks like a big sloppy mess, and I've got kind of like ADD, OCD, and I need to be under control. So please line it up for me, okay? 2 times 3 times 5 times 7 times 11. I'd appreciate that. And before you put that equal sign there, you know, you got to be careful. Some people just throw that equal sign around. I don't like that. I want to be sure. I want to be sure that if I say it's equal, it is. So multiply it out. That's how you test. If you're going to tell me that 2 times 3 times 5 times 7 is equal to 2310, you better be sure you check. So let's do that now. 2 times 3 times 5 times 7 times 11, 2310. Does it equal? Yes, it does. 2310. And I can scratch this out. All right, it does equal. Bam. Okay. Let's see. Find the least common multiple of 13 and 17. The least common multiple. If you forgot what least common multiple is, check your notes. If you missed the notes, I guess I may put a video up about what least common multiple is, because you know, it's going to take a little while to explain. I just want to go through this quiz right now, and this is not an individual lesson. The way we find the least common multiple is we take the numbers that we're interested in, and you have to have at least 2, because if you're looking for the least common multiple of one number, you screwed up. We're going to find the prime factorizations of 13 and 17. Here's the thing. A lot of people add their quiz. It looks just like this. There's like a blank here. Like here's nothing. There's nothing written there. You know why? Because they're confused. You know why they're confused? Because 13 is prime. There's only 2 numbers you can divide it by, and that's 13 and 1. So the only factors of 13 are 13 and 1. And the only factors of 17 is 17 and 1. We don't typically include 1 because it is the multiplicative identity. The multiplicative identity is a number that you can multiply other numbers by, and it doesn't change their value. So you can multiply anything by 1, and you get what you started with. You multiply 13 by 1, you get 13. So we don't usually list it. So we're right back where we started. Okay? 17 to 17, 13 to 13. Well, we don't need this then, do we? Nope. That's just a clutter. 13 and 17. The second rule of least common multiple is once you've broken them down to the prime factorizations, which we've had because they're prime, you find any factors they have in common. Do they have any factors in common? No. Okay? So what do? You multiply the other factors they don't have in common together. What factors are they that they don't have in common? 13 and 17. What's 13 times a 17? Well, I mean, I don't mean to be weak, but here we go. 13 times 17 equals 221. Okay, I expect to see some work or some sort of explanation. Notice I did a lot of work there. Please don't erase your work if you do it. That's my ticket to your mind. That's how I get to see what you think about. Okay, last one that isn't the bonus. Find the least common multiple of 24 and 16. So, you know what? Maybe I will talk about it. I see a lot of kids doing this. They're using the table. Please stop doing this. Multiple means 1 times 24 is equal to 24. 2 times 24 is equal to 48. 3 times 24 is equal to, oh man, 60, 72, and so on and so forth. I don't know my multiplication tables with 24 so great. So now we'll do 16. I'm way better at that. 1 times 16 is 16. 2 times 16 is 32. 3 times 16 is 48. 4 times 16 is, let's see, 54, 64. Okay, and so on and so forth. 24, 48, and 72, those are multiples of 24. That's what the M part means. Whoops. That's not the M. Let me get real detailed here, real fine line. The multiple. That's what the M stands for, okay? The M stands for multiple, and that's what we're talking about. 24, 48, and 72. These guys right here, these are multiples of the number 24. And on the right side here, 16, 32, 48, and 64, those are multiples of 16. And you need to understand that that's what we're talking about. Then we've got least. Least means the smallest thing. Smallest. My wife just walked in, so now I'm all sidetracked. Anyway, back to it. Least means smallest, okay? And then C is common. Not like the rapper, but like what we have in common. Like, let's say, let me see. Usually I compare myself to a student, but there's no one in here right now. So I will say that the ceiling and the walls are both white. They have that in common. That's something that they share. They share that quality. We're looking for a multiple that they have in common. Okay? So really, this is a poor example because I only worked it out to the point where they have one in common, and that's 48. This is how I introduced these common multiple. I don't intend for you to use this method. This method is slow, okay? And it doesn't utilize prime factorization at all. Sure, you can find what the least common multiple is between 24 and 16 because 24 and 16 are relatively close to one another. You don't have to work a table out too far to get to the multiple that they have in common. The more numbers I ask you to find a common multiple for, the more complicated it gets. You're going to be sitting here all day scratching your brain trying to find the least common multiple. So you have to please listen to me when I tell you to trust me and use the prime factorization method. It's so much easier. It may not seem like it's much easier to you now, but when you use prime factorization and bigger numbers, there it goes. It makes it less of a hassle. So we're going to do 24 and 16, and we're going to do it with prime factorization. 24 is the same thing as 2 times 2 times 2 times 3. All right, and 16 is the same thing as 2 times 2 times 2 times 2. So I'll go ahead and draw a line. There's 24, and that's 16. Then what you do is you find the factors, and you should know what that is from previous. Check the beginning of this video if you already forgot. That they have in common. That's 1, 2, and 3. They have 1, 2, 3 factors in common, all 2s. And every time I see one that they have in common, I list it down here. And I'm going to go ahead and do a spoiler alert. The least common multiple is going to equal 2 times 2. Notice it's in 2 places, but I only list it once because they have it in common. You don't want to list it too many times. You will get a common multiple, but not the least common. And then what's left? What's left is a 3 and a 2. They do not have a 3 and a 2 in common, so we include that 2 here, and we include that 3 here. We list the stuff that's left over at the end, okay? And if you multiply all that together, I can do this one in my head, y'all. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 3 is Well, 3 times 6 is what is 3 times 6? 18. And 3 times 10 is 30, and 30 and 18 make 48. It's been a long day, man. It's Friday. I hope you guys appreciate what I'm doing for you here. So 48, that's the least common multiple found using prime factorization. Okay, it's so fast. It's so fast. I saw some of y'all suckers trying to do the quiz using the tables, and my heart went out to you because I know that you guys were struggling. Man, I'm gonna get this down. Here we go. Bam. Last one. Last one. I got 4, 21, and 35. That's a bonus. Guess what? You got to figure this one out yourself. You got to do it. You got to do it yourself. I'm not going to work the bonuses out for you. Okay, that's special. That's kind of going above and beyond. I just expect you to know what you got here on the test, okay, on the quiz. I'm not going to do the bonuses. They take longer. It's more work, and I don't want to waste your time. It's already been 20 minutes. That's ridiculous. Anyway, peace out.